The conversation around future technology often drifts into science fiction. We picture capabilities that feel like magic. Take telepathy, direct mind-to-mind communication. It's a concept that's fascinated us for centuries. Now we're on the cusp of 6th-generation wireless, and whispers of mind reading have begun. Not extrasensory powers, a technological leap that could feel like telepathy, a seamless link between thought and the digital world. Imagine intentions becoming actions without touch or speech, a surgeon controlling a robotic arm by thought, a designer shaping a model by visualizing it, brain-computer interfaces powered by near-zero latency and massive bandwidth. The boundary between user and device dissolves. Communication tech keeps pushing for speed, lower latency, deeper integration. 4G to 5G unlocked the Internet of Things. 6G is the next exponential step. If networks process info at the speed of thought, the systemic changes will touch our economy and our everyday interactions. We'll take a systems-level, non-sensational look. This isn't just faster internet. It's a redefinition of communication. The first tangible consequence of the 6G rollout won't be a sudden shift in human consciousness. Instead, something far more practical will arrive. A new generation of personal devices. They'll create a constant high-fidelity stream of physiological and neurological data. This is the first step toward telepathic interfaces. An office worker might get a subtle haptic alert from their chair if their posture falters or attention wanes. Augmented reality becomes practical and persistent, with heavy processing offloaded to the network edge. Your heating might adjust because your biosensor noted a temperature drop during your commute. The boundary between a user giving a command and the system acting on a perceived intention will start to blur. The most immediate effect will be the network's ability to create a real-time digital twin of its environment. A surgeon in New York will be able to perform a delicate operation on a patient in Tokyo using a robotic avatar, feeling the resistance of tissue as if they were in the room. A digital billboard might change messaging based on the aggregate mood of passers-by, using anonymized biometric data. The first and most obvious winners will be the companies that build the network itself. Telecom operators, equipment manufacturers, semiconductor firms. A new gold rush will begin in the device market. Venture capital will pour into brain-computer interfaces and advanced biosensors. However, the high operational costs of 6G will reshape the economics of data itself. The enormous energy and maintenance expenses will need to be paid for. Governments and regulatory bodies will be forced to confront a new frontier of law and ethics: neuroregulation. The system-wide deployment of 6G carries a significant environmental cost. Terahertz physics require a hyperdense network. That means massive hardware production. Rapid technological obsolescence creates a massive stream of e-waste. Without a circular economy model, we risk mountains of hazardous material. A critical pathway involves rethinking the energy sources. The distributed nature of 6G makes it ideal for integration with distributed renewable generation. This new technological paradigm will also redefine social norms. How will we navigate conversations when one person has access to a stream of information the other does not? A cognitive divide could emerge, separating those who can afford enhancements from those who cannot. This goes beyond internet access. It touches the very potential of the human mind. An employer might use biosensors to monitor workers' stress and focus, but where is the line between optimization and exploitation? The world may split into competing 6th-generation ecosystems, creating a new form of digital iron curtain. This will lead to the decoupling of technology supply chains, as nations seek to reduce their dependence on hardware and software from geopolitical rivals. Nations will be reluctant to allow their citizens' most personal data to be stored or processed in data centers located in rival countries. The network's advanced sensing capabilities could be used for military surveillance, and its control over critical infrastructure makes it a prime target in cyber warfare. Decades after its initial rollout, the 6th-generation enabled world settles into a new equilibrium. The technology, once revolutionary, has become a ubiquitous and largely invisible utility. Rote memorization has become almost entirely obsolete. The value of human intellect has shifted from knowing facts to the ability to ask creative questions and synthesize information. The cognitive divide has been partially mitigated by public initiatives that treat basic BCI and AR access as a public utility, ensuring a foundational level of augmentation for all. The social contract has been rewritten. Citizens trade a constant stream of anonymized personal data for a world of immense convenience and safety. It is a more optimized world, but also one where the boundaries between the individual, the collective, the private thought, and the public data point are forever blurred. The journey into a sixth-generation powered future reveals a fundamental insight. The technology itself is neutral. It merely provides a new and more powerful canvas on which we will paint our existing human values, biases, and aspirations. Our final insight is that we are the architects of the outcome. The ultimate freedom in a sixth-generation world may be the right to be offline, the ability to choose when and how our minds interface with the global network. We will need to develop new habits and social rituals that carve out space for unmediated human interaction and reflection. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality.